Welcome to this video tutorial, one of many in a series designed to get you up and running with Leapfrog. In this video, I will introduce the workflow used to build a basic structural trend.
In a previous video, we saw how we can apply a global trend to easily modify a surface. Structural trends are similar to global trends in that they provide a method of stretching surfaces in different directions to reflect the underlying shape. However, structural trends allow the user more flexibility as you can control the strength and direction of the trend at different points in space based on a number of meshes representing different trend directions. These meshes can either be planar or curved, which lets you create complex trends that can overlap each other. The structural complexity of many areas require the flexibility and control of these structural trends. The first step is to define one or more meshes that can represent the trend of the data, like the plane does when we create a global trend. These meshes can be imported into Leapfrog or created in Leapfrog using polylines, GIS lines, or structural data, or they can be a surface extracted from a vein model. Once all the desired meshes are available, we can start by right-clicking the Structural Trends folder, New Structural Trend. I can see here is the trend mesh that I'm going to use to build my structural trend. I can add it as a trend mesh by simply clicking Add and selecting that surface. We can see there are three types of structural trends: strongest along meshes, blending, and non-decaying. We will talk about all three, but let's start with the non-decaying. Non-decaying assumes the strength of the trend doesn't decay away from the meshes. In the case of regional fabric of an area, this would be reasonable. In a non-decaying structural trend, we need to define the strength. This strength will be the ellipsoid ratios that apply in the maximum and intermediate direction when the out-of-plane direction is assigned to 1. So in this case, we have a strength 5 times stronger in the plane than we do out of the plane. Let's create this structural trend and see what it does. When the structural trend is viewed in the scene, it is a visual representation of the parameters used to define the structural trend. With this non-decaying trend, we can see that the trend is consistent across the entire area and the disk size that represents the strength remains the same. Next, we'll take a look at the strongest along meshes option. This option takes any one point in the model and then uses the closest mesh at that point to define the direction and strength of the trend. With this option, we need to define a range. The strength of the trend will decrease away from the mesh to this certain range. In this case, let's try 100. Outside of the range, there will be no more effect from the trend, as we can see here. The last option is blending. Blending takes any one point in the model, then uses a combination of multiple meshes to define the direction and strength of the trend at that point. We would need at least 2 meshes to show this option, so I won't be showing it in this basic video. Once a structural trend is created, it can be added to the surface built from categorical or numeric data, for example, an intrusion in a geological model or a grade shell built in the interpolants folder. Let's see how to apply it to our quartz porphyry intrusion that we have here. Start by double-clicking the surface of interest in the project tree, and then click on the Surfacing tab. To access the structural trends, we need to click the Additional Options. This will enable further options for editing a surface. Now we can click on the Trend tab and select the Structural Trend radio button. We only have one trend available, and so we'll click OK. Leapfrog's now going to inform us that we can't use a linear interpolant with a structural trend, so if we click OK, it will bring us to the Interpolant tab where we can select a spheroidal interpolant. Now that I've clicked OK, Leapfrog is going to regenerate my surface using the structural trend I've applied, and now we can see the outcome. More details about creating, editing, and utilizing structural trends will be available in a more advanced video tutorial.